Okay, so for this problem, it's a perpetuity-due with semi-annual payments consists of two level payments. So if I were to write this out, there'd be two level payments of 300. And starting from the third payment, each payment is 200 larger, right? 200 larger. Now, using an annual effective rate, the present value is this. Okay, so the way that I would go about this is that I could create the PQ-TVM formula starting with using time one as the comparison date. So I would do the first payment of 300 over I plus the increase over I squared. Then I would also multiply by 1 plus I to signify a perpetuity due. And another thing is that I would also, what would I also do? Oh, yes. And another thing is that I would also, since this is the comparison date of what is occurring here, and since there's one period left deferred, I would also take this and multiply it by v. And then I'd also add 300 for one more payment occurring here equals to 475,000. Now, another thing is that I could just solve. So I'm going to first get rid of these v's, right? I'm going to combine these. Right, and b. Then I move this to the other side. And I'd move this to the other side. And then I'd move all of these to the other side to form a quadratic equation. Then I could do negative b plus or minus b squared minus 4a c over 2a. Yeah, I can solve this. So I'm going to start with what is occurring here. It'd be 300 times 300 minus 4 times 200. So it's going to be 379850000. Then radical 19489.74. Now 300 on the other side. I'm going to add it because I know if I subtract it, it's going to produce a negative thing. Then I'm going to divide it by 2 times 400. And I'm going to end up getting I equals to 2.08. But this is a whole semi-annual situation, right? We need to convert it to an annual effective interest rate of I. So what I'm going to do is going to do 1.0208 to square to represent semi-annual. And then I'm going to set it equal to annual effective, and I want to find what I is equal to. So I'm going to move I one to the other side. Nice one. So I'm going to find that the answer I got was 4.203264%, which would be closest to answer E.